Welcome back. Let's get into it. Out of these particular experiments that pointed us to the subatomic particles of reality, a new field of science was born called quantum physics. Whoop, 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 whoop. I love quantum physics so much. It's my favorite thing. Okay, the solid ground we stand on isn't. This change was a complete reimagining of the world we thought we lived in, and it led to the proverbial rug being pulled out from under our feet. Feet we used to think were planted on solid ground. How so? Think back to those old toothpick and styrofoam ball models of the atom. Before quantum physics came along, people believed that an atom was made of a relatively solid nucleus with smaller, less substantial objects either located in or around it. The very idea that with a powerful enough instrument, we could measure and calculate the mass of and count the number of the subatomic particles that made up an atom, made them seem as inert as cows grazing in a pasture. Atoms seem to be made of solid stuff, right? So this is what the classical atom model looked like. This is the old school classical Newtonian version of an atom. The focus is primarily on the material. Nothing could be further from the truth, as revealed by the quantum model. Atoms are mostly empty space. Atoms are energy, attuning to whatever song we are emitting from our being. Think about this. Everything physical in your life is not solid matter. Rather, it's all fields of energy or frequency, patterns of information. All matter is more no thing than something. It's no thing like energy. Matter is more no thing, which is energy. Matter is more of energy than it is something, which is particles. So the more mass that it has is just the energetic signature that it carries as opposed to the something of it, the particles, which reminds me of that show where that gal would go in to people's houses and help them pick things, and she would ask them to hold it and say, does it bring you joy? Does the thing bring you joy? And if it didn't, like that's how they were supposed to be going through all their crap. And because the thing actually carries this energetic signature with it, and that's impacting you on some level, whether consciously or subconsciously. The quantum atom. So here's this electron cloud. It's like mostly nothingness, and then the surrounding, and then the nucleus is in the middle. I always think of the electrons as like little, I've used this analogy so many times before. So if you've listened to me, here we go again. I always think of the electrons as the little like minions, but they're neutral. They're not like good or bad. I don't know if I should just watch the freaking movie already, so I actually know what I'm referencing, because I don't know the movie. I think the guy is like evil in it. I don't know. I really don't know, so don't quote me. But the point is, the little minions that are like his helpers, the electron cloud, I feel like they're just little minions that are just running around, like picking up whatever the energy is that we're assigning to them via the observer effect, and they're doing what they are told to be doing based on the frequency that we are sending out. The new school quantum version of an atom with this electron cloud, the atom is 99.999999% energy and 0.00001% matter. It's just about nothing materially. It's just about nothing. Where's 1C? Just this big blank page. This is the most realistic model of any atom. It is no thing materially, but all things potentially. Whoop, whoop. That should be encouraging. Another puzzle. Subatomic particles and larger objects play different roles. Okay, let's get that. Subatomic particles, teensy little particles, and then the larger objects, they play different, that makes sense. Play by different rules. So the subatomic particles and the larger objects, they play by different rules. Like, freaking explain that. But this alone wasn't enough to explain the nature of reality. I keep meaning to set my timer so I know how long these videos are going. Einstein and others had another puzzle to solve. Matter didn't always seem to behave in the same ways. When physicists began observing and measuring the tiny world of the atom, they noticed that the subatomic level, the fundamental elements of the atom didn't obey the laws of classical physics the way that larger objects did. Events involving objects in the large world were predictable, reproducible, and consistent. Events involving objects in the large world were predictable, reproducible, and consistent. When the legendary apple fell from a tree and moved toward the center of the earth until it collided with Newton's head, its mass accelerated with a consistent force. But electrons, as particles, behaved in unpredictable, unusual ways. That's why I call them like the minions, because they're like, they're all over the place. When they interacted with the nucleus of the atom and moved toward its center, they gained and lost energy, appeared and disappeared, seemed to show up all over the place without regard to the boundaries of time and space. Did the world of the small and the world of the large operate under very different sets of rules? Since subatomic particles like electrons were the building blocks of everything in nature, how could they be subject to one set of rules and the things that they made up behave according to another set of rules? Like they combine to make something up. So it's like, how does that happen? How does that happen? Particle from matter to energy. Particles pull off the ultimate vanishing act. From matter to energy. At the level of electrons, scientists can measure energy-dependent characteristics such as wavelength, voltage potentials, and the like. But these particles have a mass that is so infinitesimally small. Whew. But these particles have a mass that is so infinitesimally small and exists so temporarily as to be almost non-existent. This is what makes the subatomic world unique. It possesses not just physical qualities, but also energetic qualities. In truth, matter on a subatomic level exists as a momentary phenomenon. It's so elusive that it constantly appears and disappears, appearing into 3 dimensions and disappearing into nothing, into the quantum field, in no space, no time, transforming from particle matter to wave energy and vice versa. But where do particles go when they vanish into thin air? Where do they go?